In this problem, we're being asked to find the solution to the differential equation. The first thing that happens to most people on a problem like this is they see that word differential equation and they just start freaking out because it comes with a lot of baggage. The reality is that word just means one thing. It means derivative. And we've been dealing with derivatives for this whole class. So nothing scary there. It's just a fancy math way of saying the derivative equation. So we have dy dx, that's our differential equation. And they want us to find the solution to that differential equation. Well, to find the solution to a derivative, right, we undo that derivative. We take the antiderivative. So we're going to take our equation, dy dx equals x to the third over y, and we need to find the antiderivative of that. What ends up happening next to people is they start freaking out because they say, oh, well, I've taken the antiderivative, the integral of an x equation before, but nothing with x's and y's mixing together. And so here, this is sort of bells and whistles going off that this is what we call a separable differential equation. And the name, says it all. We want to separate this equation so that the x's are with the x's and the y's go with the y's. So anytime you're in one of these, you just do that game to start with. So get all your y pieces together on one side. So I'm going to multiply the y over to the other side to meet up with that dy. Get it out of the bottom there. And then the next thing I need to do is I need to get that dx piece to get over with the x's. So again, treat them like their own variables. So I multiply both sides by dx, and I'm left with y dy equals x cubed dx. Now we're basically where we need to be because this looks just like it needs an integral symbol up in the front. And that's what you're going to do now, is you're basically going to take the antiderivative of these two equations, working them separately. So on the left-hand side here, the antiderivative of y dy, that's just going to be our straight-up power rule, right? That's nothing fancy there. We're just going to add 1 to the power, divide by the new power. So we've got an unwritten 1 on that. We add 1 to the power, and then divide by the new power. When you're dealing with these differential equation setups and you got two integrals, you only need 1 plus c for the entire equation. And that plus c is always going to be better if you put it on the x portion. So done with this side. Going to the next, again, power rule on this antiderivative. We add 1 to the power, divide by the new power, and now we put our plus c in here that we were looking at. So that 1 plus c handles the entire equation. To finish this out, we need to get to a y equals, right? You notice that your answers up above, all of them are a y equals equation, and that's where we need to go. So we're going to start by multiplying both sides by 2 to get it out of the bottom here. And so on this side, we're left with y squared equals, and then we'll distribute the 2 into here. So 2 times x to the 4th over 4, the 2 and the 4, right, they're going to simplify down. That's really going to be a 1/2. So we end up with x to the 4th over 2 plus, and when you multiply a constant by a constant, we don't know what that c is, so we're just going to call it c. We just kind of keep building to it. If you had to subtract from it, you just call it again plus c. Divide it, plus c. So keep that plus c as a plus c. Our next move here is we are going to need to square root both sides. So we square root both sides of this equation, and we get out of here y equals, and because we put the square root into place, we get the square root of x to the 4th over 2 plus c. From there, the mission now becomes we need to find out what that plus c value is. And so what you'll do is you're going to start by breaking this up into basically 2 separate math problems. We've got one for when y equals the positive square root of x to the 4th over 2 plus c. And then we'll have another problem that we have to solve that is y equals the negative square root of x to the 4th over 2 plus c. To find our plus c value, that's where this initial condition that they give you comes into play. So what they're doing is they're giving us a point that has to be on this graph. So they're telling us right now that when we plug in x as 2, we need the answer, when we plug in x as 0, we need the answer to all of that math to end up equaling 2. And so we just set up that little math problem. So instead of y, you would have the answer you're looking for. So 2 is going to equal the square root of plugging in 0 everywhere I see an x, so 0 to the 4th over 2 plus c. Simplifying that down, we get 2 equals 0 divided by anything is 0, so 0 plus c is going to just get us the square root of c. And now we need to go ahead and square that to cancel out the square roots. So we square both sides, and we see that 4 equals c. So right now, our full answer on this side is going to take that equation and that plus c, and we get our specific solution here. This would be x to the 4th over 2, and then plus 4. Play the same game on the other side. And you're like, Blue, there's only one answer up above. How am I going to get it down to one answer from both of these? And we'll answer that at the very end here. So same idea on this one. We're going to be taking that initial condition, y of 0 equals 2. So we'll set this equation equal to 2, and then we will plug in 0 everywhere we see an x. Little bit of extra algebra. We got to get that negative off there before we square both sides. So we'll pull the negative to the other side. We end up with negative 2 equals 0 again is going to cancel out, and we'll end up with c right here. And then just like we did on the other side, we're going to square both sides of this to cancel out the squared, and we end up with 4 equals c. So then the final answer on this side, our final option becomes the specific formula, y equals the negative square root of x to the 4th over 2, and then we put that plus 4 on there. So here you'd say, okay, I've got two answers, and how convenient of them, both answers show up above here, right? They always tell you, it's one of those things you kind of forget about. They say check for extraneous solutions. What we know is that when we plug in 0, this thing has to equal 2. And sometimes when you're squaring stuff, they call it squaring in an answer. And so you need to check at the very end here that that 0 equals 2 still works. So plugging into this first equation, if I plug in 0 everywhere, I get 0 to the 4th over 2 plus 4. That gets me y equals the square root of 4, and that equals 2. So right now, that still checks for this equation that we have here. If I go and do the same check on the other side, plugging into our negative here, so I would say y equals the negative square root, plugging in 0 for x, so 0 to the 4th over 4 plus 4. You'll see that I squared in this negative. This is equal to negative square root of 4, which equals negative 2. And negative 2 is not what we want for our answer, so this is definitely not going to be our answer on this problem. And it's only this other one here. So sometimes you got to do that little bit of extra work just to make sure you didn't square in an extra answer. Thanks for watching my video. If you liked it, please click that like button and subscribe. And also share it with your friends and anyone else you know who might be crying about an upcoming AP Calc test. You can find more videos from me, more sample AP Calc questions, and my complete AP Calc study guide over at my website, apcalcprep.com. Have a great one.